Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course. Securing virtual machines. In general, the security of a virtual operating system is the equivalent of that of a physical machine OS. The VM should be updated to the latest service pack. If you have multiple VMs, especially ones that will interact with each other, they make sure they are updated in the same manner. This will help to ensure patch compatibility between VMs. A VM should have the newest AV definitions, perhaps have a personal firewall, have a strong password, and so on. However, there are several things to watch out for that, if not addressed, could cause all your work compartmentalization operating systems to go down the drain. This includes considerations for the virtual machine OS as well as the controlling virtual machine software first. Make sure you are using the current and updated virtual machine software. Update to the latest patch for the software using, for example, the latest version of Oracle VirtualBox. Configure any applicable security settings or options in the virtual machine software. Once this is done, you can go ahead and create your virtual machines, keeping in mind the concept of standardized imaging mentioned earlier. Next, keep an eye out for your network shares and other connections between the virtual machines and the physical machine, or between two VMs. Normally, malicious software cannot travel between a VM and another VM or a physical machine as long as they are properly separated. But if active network shares are between the two, creating the potential for a direct traversal vulnerability, the malware could spread from one system to another. If a network share is needed, map it, use it, and then disconnect when you're finished. If you need network shares between two VMs, document what they are and which systems and users connect to them. Review the shares often to see whether they are still necessary. Be careful with VMs that use a bridged or similar network connection instead of a network address translation (NAT). This method connects directly with other physical systems on the network and can allow for malware and attacks to traverse the bridge, so to speak. Any of these things can lead to a failure of the VM's isolation. Consequently, if a user or malware breaks out of a virtual machine and is able to interact with the host operating system, it is known as virtual machine escape. Vulnerabilities to virtual hosting software include buffer overflows, remote code execution, and directory traversals. Just another reason for the security administrator to keep on top of the latest CVEs and close those unnecessary network shares and connections. Going further, if a virtual host is attached to a network attached storage NES device or to a storage area network SAN, it is recommended to segment the storage devices off the LAN, either physically or with a secure VLAN, regardless of where the virtual host is located. Secure it with a strong firewall and disallow unprotected file transfer protocols such as FTP and Telnet. Consider disabling any unnecessary hardware from within the virtual machine, such as optical drives, USB ports, and so on. If some type of removable media is necessary, enable device, make use of it, and then disable it immediately after finishing. Also, devices can be disabled from the virtual machine software itself. The boot priority in the virtual BIOS should also be configured so that the hard drive is booted from first, not any removable media or network connection unless necessary in your environment. Due to the fact that VMs use a lot of physical resources of the computer, a compromised VM can be a threat in the form of a denial of service attack. To mitigate this, set a limit on the amount of resources any particular VM can utilize and periodically monitor the usage of VMs. However, be careful of monitoring VMs. Most virtual software offers the ability to monitor various VMs from the main host, but this feature can also be exploited. Be sure to limit monitoring, enable it only for authorized users, and disable it whenever not necessary. Speaking of resources, the more VMs you have, the more important resource conversation comes. Also, the more VMs that are created over time, the harder they are to manage. This can lead to virtualization sprawl. VM sprawl is when there are too many VMs for an administrator to manage properly. To help reduce the problem, a security administrator might create an organized library of virtual machine images. The admin might also use a virtual machine lifecycle management (VMLM) tool. This can help to enforce how VMs are created, used, deployed, and archived. Finally, be sure to protect the raw virtual disk file. A disaster on the raw virtual disk can be tantamount to a physical disk disaster. Look into settings permissions as to who can access the folder where the VM files are stored. If your virtual machine software supports logging and or auditing, consider implementing it so that you can see exactly who started and stopped the virtual machine and when. Otherwise, you can audit the folder where the VM files are located. Finally, consider making a copy of the virtual machine or virtual disk file, also known as a snapshot or checkpoint, encrypting the VM disk file and digitally signing the VM and validating that signature prior to usage. One last comment: a VM should be secure as possible, but in general, because the host operating system is in a controlling position, it is likely to be more easily exploited, and a compromise to the hosting computer probably means a compromise to any guest operating system it contains. Therefore, if possible, the host should be given even more secure than the VMs it controls. So the harder your heart to harden the VM, make sure the hosting OS is solid as a rock. Chapter summary. This chapter focused on the hardening of operating systems and the securing of virtual operating systems. Out of the box operating systems can often be insecure for a variety of reasons, and the need to be hardened to meet your organization's policies, trusted operating systems, TOS compliance and government regulations, but in general they need to be hardened so that they can be more difficult to compromise. The process of hardening an operating system includes removing unnecessary service and applications, whitelisting and blacklisting applications, using anti-malware applications, configuring software-based firewalls, updating and patching, as well as managing those patches, using group policies, security templates, baselining, utilizing a secure file system, and performing preventive maintenance on hard drives, and in general keeping a well-maintained computer. That's a lot of work, especially for one person. That makes the use of automation very important. Automate your work whenever you can through the use of templates, the imaging of systems, and by using workflow methods. These things, in conjunction with well-written policies, can help you or your team to get the work done faster and more efficiently. One great way to be more efficient and possibly more secure is by using virtualization. The creation of a virtual machine or other emulator that runs in a virtual environment instead of requiring its own physical computer. It renders dual booting pretty much unnecessary and can offer a lot of options when it comes to compartmentalization portability. The virtual machine runs in a hypervisor, either type 1, which is known as bare metal, or type 2, which is hosted. Type 1 is faster, more efficient, but usually more expensive and requires great administrative skill. Regardless of the type you use, the hypervisor and the virtual machine it contains needs to be secured. The hosting operating system, if there is one, should be hardened appropriately. The security administrator should update the virtual machine software to the latest version and configurable applicable security settings for it. Individual virtual machines should have their virtual BIOS secured, and the virtual machine itself should be hardened the same way a regular non-virtual operating system should be. That clarification is important because many organizations today have more virtual servers than non-virtual servers. The term regular becomes inaccurate in some scenarios. Unnecessary hardware should be disabled and network connections should be very carefully planned and monitored. In addition, the administrator should consider setting limits on the resources a virtual machine can consume, monitor the virtual machine and its files, and protect the virtual machine through file permissions and encryption. And of course, all virtual systems should be tested thoroughly before being placed into production. It's the implementation of security controls testing that will ensure compatibility between VMs and virtual hosting software, reduce the chances of exploitation and offer greater efficiency and less downtime in the long run. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.